In this program, I am Carol, a licensed independent at YourLibrary, and I'd like to welcome you to the first of our science programs at the library. For a long time, I've been wanting to host some kind of a science for people thing at the library, and tonight I'm so happy to be partnering with the New Alliance for Science, and we have an exciting week ahead. Thank you for coming in.
involve folks from other islands. So, but us on Kauai, we're kind of the first ones to be organizing activities like this, but we're hoping that our colleagues on Maui and the Big Island and Oahu will also start with similar kinds of activities. There's a few little handouts from Cornell Alliance for Science up front too, if you'd like to take them with you. And again, sign up on the email list, and we have Facebook and Instagram, all those things, website, so you can learn more. Any other questions? Okay, thank you. Thanks again for coming.
Well, I'd like to say aloha, everyone, and I particularly would like to thank our hosts, Carolyn Larson and for the Louis Public Library, and Sarah, Diane, and the Alliance for Science. It's a group that I very much want to be involved in, and both as the library and the Alliance for Science, and so I want to thank them very much for drafting me to kick it off. And so let's give it a start. So how many people have seen the show Wicked Tuna? Anybody? Okay, so a couple. So tonight I want to hopefully provide a little bit of information about the really exciting tunas, which I'm sure most of you know. You've either eaten them or chased them or caught them. And to give you sort of the history of how we got to understand some of the migration routes and learn about these fish that are really hard to study. And I'm going to give you my takeaway at the start, and that the people that are not acknowledged at the front, many, many people have helped us to learn this knowledge. And the biggest stars of that partnership are mostly our fishermen partners. So let's tell you the stories of the tuna. And I'm sorry we're in a layout that I have to turn my back, but so the Wicked Tuna Show has captured the imagination of so many people around the world, and it's turned the tuna into basically a sexy rock star of the ocean. And on the right you see, I've no one saying, oh, that's Wicked Tuna, Dave Marciano, and then his nemesis on the other side. But really, we've been working with fishermen since 1993 to understand this really amazing fish. It's one of the top predators in the ocean, and you'll see in the next few slides why it's so spectacular, and it's the big sister, the big brother of your local Aki, yellowfin and big eye. But I want you to also know that on Kauai and on the other islands, there is wicked good tuna science going on because your fellow fishermen and residents want to understand tunas that are found here in the main Hawaiians as much as the fishermen in New England and Canada wanted to learn about bluefin. So this partnership was really started in the Pacific with the full intention and enthusiasm of our local fishermen. And I have a feeling you're going to recognize some of the people in the slides to come. So how about a little bit about bluefin biology? You're looking at the biggest tuna in the ocean. And bluefin grow up to 12 feet. They are highly prized by many people around the world. They've been studied since before the time of Christ and eaten in the Mediterranean. They live long. They travel the seas. The tuna on the left is a fisherman from Ireland, and on the right you'll see a group of fishermen that are actually our tuna taggers, and that's in Nova Scotia. And they happen to land 1,000-pound tuna, so that's known as a grander. But that gives you the idea of how big these large tunas and billfish can be. And the billfishes include the marlins, the swordfish that you might have eaten, and they're also, like the bluefin tuna and the Aki, highly migratory. Because they're highly migratory and long-lived, they're hard to study. And they have many, many mysteries that are still hidden to science. And so our goal is to learn much more about them so we can make sure that they're there for your kids and your grandchildren. So you just saw the picture of the 12-foot, 1,000-pound bluefin. These fish start out as little 1-millimeter larvae. And that picture up there is a 2-millimeter bluefin larvae on the top, and below it are sailfish larvae, so they're billfish. And they grow really quickly And if I put that picture next to the 12-foot tuna, you wouldn't be able to see the larvae. And so that's just how incredible they are. Over their lifetime, they grow like crazy. So why do we care about tuna? Who doesn't like poke? Who doesn't like a beautiful can of albacore? Tunas are consumed around the world. They're an incredible source of food security for many Pacific Islands, nations. They're used as food for our military. They're put in foil packages. And almost all parts of tuna are eaten, including on the right. I have a bluefin head because, believe it or not, the eyeballs from New England giant bluefin are shipped to Atlanta, and they're sent to Japan and to Korea because the eyeballs are also highly prized. So tunas are incredibly valuable as far as humans. And that's why we want to make sure we understand their biology and their life history. And it goes without saying to you local guys, hey, they're a lot of fun to catch. And so fishermen that we work with are involved very much in not just tagging, harvesting, catching, releasing. On the left is Curtis Matsumura with his 700-pound blue marlin, was a winner in the Garden Isle, the Trollers tournament last year. So tuna are incredibly important to everybody. So who's in charge of the tuna fisheries? This is where it gets a little more complicated. What you see in the picture on the top are a group of scientists sitting in a table in Madrid, and their job is to conduct stock assessments and population assessments for the tuna species. And most of these species cross boundaries, and so they're managed internationally by what we call regional fisheries management organizations. So the scientists come up with an understanding of the populations, and then in the lower left, you see a picture of the U.S. delegation in Madrid, and these are federal managers, environmental policy advocates, politicians, and now even judges that are making policy and setting quotas for the tunas around the world. So it's complicated. So your fishing on Kauai will go all the way to managers and scientists sitting in Honolulu, and then go even further to Pacific-wide organizations. So it's a big system of people working to understand what's out there. Stock assessments are almost always based on statistical models that describe the population. It's very hard to go out and count these highly migratory fish, even though we try it. And then these stock assessments that many fishermen have problems with, they include a lot of assumptions about fish biology. And the real question is, are they accurate? Are they correct? It's our job as marine biologists and scientists to find the best information, right? Because you want to get it right. So this is how we got into bluefin in 1993. It starts with a problem. The problem is that New England fishermen said, hey, wait a minute. Assessments say bluefin tuna are going extinct in the Atlantic. There's only 7,000 adults left that are estimated by the population assessment, supposedly the spawners. The men there you see are spotter pilots that fly for boats to harvest bluefin in the Atlantic. And as you can see from their signs, they said, we see more bluefin in the Gulf of Maine, where they're flying to catch fish, that the assessment says exist in the entire Atlantic Ocean. And in fact, they say one school can have as many fish as they've said exist in the Atlantic. And nobody believed them. And the federal scientists did not want to go up in the plains to see what they were doing. And so they asked us to. So this is the story about bluefin biology and how we went from a state of not knowing, with fishermen's help, to having better knowing, better understanding. What you're seeing there are simple ID tags that Frank Mather, who was an early fisherman and scientist working in the 50s, he decided that he wanted to know where bluefin went. He thought they traveled far. So Frank Mather put simple ID pieces of plastic on bluefin that he caught in the Bahamas. You could see off Florida. And those lines show you the recaptured locations at the end of those 7 bluefin that Frank tagged and then were recaptured by fishermen at some time in the future. And from the early days, those simple tags showed that bluefin were crossing the Atlantic. In as little as 55 days, a couple of Frank's tunas were recaptured in Norway. by purse seiners. So all along, from early days, biologists knew that bluefin were highly migratory and could make transatlantic crossings and could make transequatorial crossings. And that's pretty exciting. And that was 1960s knowledge. So, okay, so what did they do with it? Well, the problem in the Atlantic is that Atlantic bluefin tuna, their population has been in dispute since about 1981 when the managers started the organization. So I'm sorry I don't have a pointer, but basically the assumptions about bluefin were that there are two separate stocks in the Atlantic. That red line is a 45-degree parallel, and they said that bluefin on one side of the Atlantic don't cross to the other side. And that was based on a simple assumption. The yellow areas that you see there are the known spawning grounds for bluefin tuna. In the Mediterranean, they're supposed to be spawning where you see, and in the Western Atlantic, they're supposed to only spawn in the Gulf of Mexico. And the assumptions were that those bluefin didn't cross, they didn't mix, and they never changed their spawning grounds. So therefore, you can manage these bluefin as two separate stocks. So whatever happened in the Med didn't affect what happened in the US in our fisheries or Canadian fisheries. And that has been the assumption and is still the assumption to this day. But bluefin fishermen said, wait a minute, we know that bluefin don't stop at that line. And so whatever's going on, the overfishing in the Med, is affecting our fisheries. And all these problems come down to lack of control in the Mediterranean. So I'm trying to give you a taste of the challenges and the problems that go with tuna, fisheries and management. And you could think about how they may apply or may not apply to our own fisheries here in Hawaii and in the Pacific. So, okay, let's get to some nice pictures. Bluefin are the most beautiful things to see, whether from a boat, from a pulpit on a harpoon boat, or from a spotter plane, which is where we spent 3 or 4 years. They're simply gorgeous. Those are giant bluefin. Our spotter has flown very low to get that picture. So in the early days, my lab started out counting fish from spotter planes, trying to use acoustic methods. You'll see my grad students and our collaborators basically trying to count tuna because we felt that catch statistics alone for highly migratory fish are not going to tell the whole story. They're only going to tell you what you catch, not what's out there. So remember that the spotter pilots were protesting, saying there are only, what they said, the 7,000 adult fish left had to be bogus. And the very first 3 weeks of surveying in 1993, conducted by spotter pilots and their fishing boats with us, giving them cameras and GPSs and laptops, were very quick to show that in fact the fishermen were right. That there were far more bluefin, and even in the New England area alone, than federal regulators and assessment scientists said there were. So you're looking at a school of just 5,000 giant bluefin at the surface alone. That's a three-dimensional school, and the shadow on the left is the spotter plane. So this kind of information was revolutionary. It didn't change assessment much. It didn't change how stock assessments were made, but it changed the perception that bluefin were on the brink of extinction, and it was political. And that's how bluefin fishermen understood that they could participate in the science and change understanding. And that's the message, I think, that why we've been successful at least gaining knowledge about bluefin is because of fishermen partners that brought these problems to our attention. So let's talk a little bit, before we get to ahi and local stories, let's talk about the wicked bluefin. Why are bluefin so cool? They are the only warm-bodied tuna out there. Do you know what warm-bodied means? It means that their body temperatures are as much as 18 degrees warmer than the water they're in. And so bluefin tuna, like porbeagle sharks, are among the few fish in the ocean that stay warm. They're not mammals, they're not warm-blooded, but they're warm-bodied. They have a beautiful body design, they're torpedo-shaped. You know they're already highly migratory. They live at least 25 years. Southern bluefin up to 40. They grow very fast. And the gill area, I know you all know where the gills are. They're the largest gill surface area in all the fish. So they have a huge respiratory capacity. They have the highest metabolic rate. their scope for activity of all the fishes, the bony fishes, and because they're warm-bodied, they can stay in very cold water. Their environment goes from 32 degrees, freezing, all the way up to 80 or 82 degrees over their migration paths. They warm their gut so they can digest their food faster. That makes them an incredible eating machine. They warm their eyes so their neural conduction goes fast, so that makes them an incredible sensory machine and predator. What did I leave out? That's about it.
How do you determine age?
We determine age with ear bones in the head of the tuna, like many. So the bluefin tuna's body, and most of the tunas, in fact, is so perfectly shaped for hydrodynamics that the Navy had MIT-designed robo-tunas. They're autonomous vehicles based on the body plan of bluefin tuna. They can retract their fins into their body, they can put their fins down, and they can be incredibly streamlined. So bluefin tuna are an optimal machine as far as their design. So let's get to how do we figure out what their migration routes are. So I'm hoping that the students that are here, you get a little bit of technology on how we track fishes and sharks. I'm going to give you a little mini history. So remember I said that Frank Mather used a simple spaghetti tag or an ID tag to figure out where fish were going. The challenge here is that that's called fishery-dependent tagging. A fisherman or somebody has to catch that fish and report the tag to get any information on what the fish has done. So that's called fishery-dependent. So in the 90s, and so some of those darts are down on the bottom, and even the type of hook or dart that's in a fish have been used to tell where fish have come from. For example, Japanese darts or hooks or European in the Mediterranean hooks have helped people figure out, oh, that fish might have come from the Med, because that hook is only used by Sicilian fishermen. But in the 90s, we were able to use computers. And so what you're looking at are implanted data loggers that have to go in the body of the fish, like in the belly cavity. So these things record with their sensors depth of pressure and temperature, and some of them have light stalks, and I'll tell you about that in a second. These are implanted in the bodies of fishes, and then you let the fish go, and then if we're lucky enough to have the fish recaptured and a fisherman returns the tag, you get incredible amounts of data. And of course, fisherman has to know that there's something in it, and most people offer pretty good rewards to get that data back. So it's a good investment. So tags go out, or signs like we have right here for our Pacific tag doggy. Oh, it's worth money if you get that back. But what's more exciting to us is the data. Okay, so this I think is, I wish I had one with me. They're over in Oahu, but what has revolutionized animal tracking, fish tracking for us, is that we take that data logger and we make it fishery independent. So you take your computer with the sensors, we attach it to the fish via a tether, and there's a dart in the bottom. And our fishermen partners dart that anchor into the base of the second dorsal fin, so the second fin, and we ask that computer, the data logger, it's called a pop-up satellite archival tag, to stay on the fish for 1 year. That's about the limit of the battery and everything else. So what you're looking at, that's about this big. It looks like a cigar with an egg and a whip antenna. And in the base of the tag, you see the light sensors. And so we ask that tag to stay on the fish. It's going to swim up behind the fish, and it's recording pressure, temperature, and light for as long as that tag stays on. They're programmed at some point, hopefully a year later, the tag, the nose cone corrodes through. The computer chip sends a signal to the nose cone. In the presence of seawater, the 18-gauge wire in the nose corrodes, and what happens is that tag, the little pin comes out, the dart's left in the fish with an ID tag, and that satellite tag, the black egg, is afloat. And that float allows the tag, it's positively buoyant, so it pops up to the surface and starts transmitting. It starts transmitting the data that's been logged on the data logger, and it's transmitted to receivers on orbiting satellite, and then that data is then sent to someone like us as email. And we get the data off the tag in about 2 weeks. So you can get that this is the way we get the data without that fish ever having to be recaptured. And that's pretty exciting. because it's finally fishery independent. The super cool thing, or let's call it a limitation, is, well, how do we know where that fish was? It's not a turtle, and it's not a marine mammal, or even a shark that might come up to the surface and spend a long time. We can't use GPS. So we have to find a way to figure out where the fish was when we couldn't track it, when it wasn't at the surface. So we use light-based geolocation. If you're a sailor, if you know about astronomy, where every place on Earth has a unique time of sunrise and sunset. So we use the shape of the light curves, just like the Polynesian, probably navigators, to estimate latitude and longitude for each day that the tag was on the fish. And so we call that light-based geolocation, and for every day, we estimate the latitude and longitude. The error is about 60 miles. At worst, sometimes much better. So with that, that's a long story, but that's how we track the tunas and the billfish these days. Our fishermen partners have been helping us put these pop-up satellite tags on tunas, and they've been helping us actually develop the methods of handling the fish so that the fish are in super shape. And over the years, we've worked on purse seiners, longliners, recreational boats, and commercial rod and reel boats to figure out the best way to handle fish so that they survive. And did I mention, the tags each cost $4,000 a piece. So let's talk about the investment of the technology. Without the fishermen to help us figure out how to set up that tether and the dart and the crimps, we would not know how to do it. So fishermen partners have allowed us to be incredibly successful at keeping tags on a giant bluefin or keeping them on the ahi. And in the lower corner you see the implanted tags. We have used those where we insert the data loggers in the belly, but honestly we've only gotten 4 back in the entire Atlantic over 10 years because the fish are mixing. So fishery independent tags are really a great tool, finally. And we've put tags on with fishermen in almost every environment. From you're looking at southwest Nova Scotia on a very cold day, you see the tagging pole. We put over 400 tags out with Canadian fishermen on giant bluefin and Cape Cod fishermen. And another thing is sometimes, rarely, but it happens, fishermen will catch that bluefin which still has the tag attached. I don't know if Wicked Tuna, that's Scott Prentice from the first year of Wicked Tuna, he was lucky enough to capture a tuna with the tag still in it. And if you get that tag back, you get even more data off of it because it's basically logs data every minute. So it's worth the money, it's worth the reward, and it's worth engaging our fleet and knowing that they're out there. Okay, so to finish the bluefin story, question? Sure.
Yeah, when the tag comes off and it's just floating in the water,
Yeah.
does it like go away or does it just float in the water forever?
That's a really good question. The tags aren't meant to be recovered because, particularly here, they would just drift all the way to, but believe it or not, they are recovered. They've ended up on islands, on beaches, but you're right. They're meant to basically float away. But sharks do eat them. Predators pick them up. I could tell you stories. You could see when a killer whale eats the tag because sometimes we get the tag data back because they regurgitate. And I could tell you for an hour all the tag stories we have about recovered tags and how we got them, including a tag on Ni'ihau that Jen helped us get back. But yeah, and I think hopefully sometime there'll be dissolvable tags, so there's no debris. But for now, the hundreds and hundreds that are out there are basically ocean debris and sometimes eaten. So what did we learn from satellite tagging in the Atlantic? What I want to show you are just 4 examples of bluefin tracks for 1 year each. The colors of the track that you see there show the month. So the warmer colors are the warmer months, and the cooler colors, the blue and the whites, are the winter months. These tags we put them all out with fishermen in New England and Canada, and they're all 1 year tracks. But notice that the beginning, where fish is released, is the green. The red triangle is where the tag popped off. So the fish is still swimming, remember. That's just where the tag is. And the data allows us to reconstruct those tracks And with each of those tracks, we have the temperature and depth record for almost every 4 minutes that the tag was on. And so, but what I want you to notice more than anything is, if you remember, and you probably don't, all bluefin tuna in the Atlantic are supposed to spawn in the Gulf of Mexico. Well, lo and behold, from the first year of tagging, only 20 to 30% of the adult fish that we tagged went to the known spawning ground. The majority of the fish didn't go to the spawning ground. So the status quo would be the upper right panel, where fish are supposed to spawn there in April and May. But again, every year since 1999, the vast majority of our tags don't go to the known spawning ground. So it doesn't make you wonder, so where are they spawning? And so all along, this is going, bluefin tuna are still presumed to spawn, until very recently, only in the Gulf of Mexico. So, okay, so I'd like to finish the bluefin story with a kind of really cool example. So what you're looking at is the 1-year track of a 700-pound bluefin that our fishermen released with us off Riverport, Nova Scotia. The tag was on a year. And notice where it went. I know it's the Atlantic, but over to the right, that fish swam past the Azores Island and turned around, went down to the Bahamas in the kind of the early spring, and then headed right back up the coast, or to have it backwards, basically returned a year later, and the tag popped off 20 miles from where we tagged the fish, off Riverport. Okay, so that's pretty cool. It crossed the Atlantic, it came back, it probably didn't spawn in the Gulf of Mexico. Well, that's pretty cool, 20 miles away. But it gets better than that. Okay, this is a blow-up of the start point and the end point of that fish. 2 weeks after the tag reported, and we got the data, as the data's coming in, guess what? This is fisherman Garth Nickerson. Garth is one of the Southwest Nova Scotia fishermen. Garth called and said, "Hey, I got your fish." The tether of the tag, of the pop-up satellite tag, was in the fish that he had just caught that morning. Guess where he was? He caught that fish on the very same anchor we caught the fish on the year before. That fish went right back after crossing the Atlantic to the Azores to the exact location that it was released on. What does that tell you? That it blows your mind, but what's really interesting, for almost every fish, whether it was a swordfish, Atlantic bigeye, or bluefin, almost every fish that kept a tag on for a year was back where we released it, or fishermen released it on. How fish navigate, we really don't know the full story, but they have a map sense, and it's been unexplored. So hopefully you guys, you young ones, figure it out. But it's incredibly, and so the last bluefin slide, I'll show you a little clip, but we were the 6 months behind the first group, Stanford, to tag with satellite tag, pop-up tags. The blue is all of the work that our labs and our collaborators did, and you can see now the story is coming together from satellite tag, is that these are all the paths from pop-up satellite tags. And the red tags are the federal government's Gulf of Mexico. And we're now seeing that fish are even crossing into the Mediterranean. So the assumptions of spawning site fidelity, and even the whole idea of 2 populations or more, may be totally out the window. And we've been predicting that bluefin spawn elsewhere, and you'll see that it's finally been verified. But I think an important question for you fishermen, too, is, like, why migrate to begin with? Particularly here in Hawaii, you've got it all, you've got food, but bluefin tuna are a pretty good example. Why migrate? So that's lunch for bluefin. That's basically a stomach full of herring. Bluefin eat about 6 to 10% of their body weight per day. But what they're doing is on the foraging grounds. And so on the right is an ovary, the egg sac of a female bluefin, and that fish wasn't spawning when it was captured, but on the right, that's a fat pad. And believe it or not, bluefin tuna put a lot of fat on their eggs and sperm sacs. And that fat is unique because right before they're ready to spawn, all of that fat quickly goes across and creates the lipids and the energy to make the eggs and the sperm for the tuna. And fat stores are important. So fish like big eye and bluefin have to eat so much food, and then they have an awful high energy demand, and they make their eggs and their sperm with that energy that they put on their gonads. So gonads are very important to fish that are eating machines, and that's an unfortunate bluefish. That's lunch for a giant bluefin. And in the spawning grounds, that's a student's boot, and that's the size of the egg sac of a giant bluefin. It's in spawning condition. So that's a lot of energy. So I personally think that it's a huge mistake for fisheries assessment to ignore the basics of spawning grounds and reproduction. Knowing where they are is crucial for understanding the population and for population's assessment. And also, it's a lot more complicated that sometimes assessment scientists know. Bluefin migrations and habitats are more complex than expected, and spawning site fidelity, that's been the basis for management, is in question. And in 2013, our colleagues, that shows a bluefin going into the med. Finally, the smoking gun. We predicted that larvae would be found in all these other places where bluefin go. And in 2013, our colleagues found the larvae on the Slope Sea on the east side of the Gulf Stream, and we were finally vindicated. The fishermen were right, multiple spawning grounds, and let's see what assessment scientists do with that. So, okay, I said we talk about tunas to give you a little more taste of beyond bluefin, big eye. I know it's poke here. This is John Caldwell, Captain Caldwell, putting a satellite tag on that's a longliner, and his crew member tagging big eye. Scotty Durbinowitz, if you watch Sword, Life on the Line, that's a deadliest catch. So Scotty's another one of our tagging captains. He tagged with a long line approach and a tagging pole. His fish was captured a year later by a very beautiful boat with the tag still attached. He's holding the tag. So again, fishermen are participating to learn more about these fish. This was the first tracks of Atlantic big eye. This is the kind of thing we hope to do here with our fishermen partners to understand Pacific and main Hawaiian Island big eye travels. And those are individual tracks. And just to make you believe me when I say that bluefin returned to where they were tagged, that's a single big eye. And you could see that it was tagged off of New England in the canyons, and a year later was pretty much back to where it was released. But notice that fish, that big eye, swam all the way down to the mouth of the Amazon. We don't know what it's doing down there. We don't know where that fish spawned. Nobody else does either. But pretty amazing information that you can get in these tags. All right, let's get to Hawaii and to Kauai.
Can I ask a quick question?
Sure.
What is the actual process of spawning and fertilization of the eggs? How does that happen?
Well, it's not usually observed, but what they do is they, we know that the female, there's video, the female, whatever the trigger is, whether it's hormonal or behavioral, the female will do a burst and the males will track her. I bet there's fishermen that have seen it. They'll chase her and she releases her eggs, and the males swim through and they release a cloud of milt, and they swim around and they accelerate, and it seems like that mixes and fertilizes the eggs. And so that's
Just anywhere in the open ocean? It's not like a
where the
shallow
larvae,
water?
they need to be where the larvae can develop. So it's not about the mothers and fathers, it's about the larvae and being in the right temperature and the right productivity. So it's really about the larvae. Once they spawn, it's all about the larvae. So, and that's a good question, and there's not a whole lot known about it. So, yeah, so none of these guys are here tonight. They've heard this all before, but I can't tell how pleased we were that main Hawaiian Islands fishermen across the island said, hey, we want to learn more about our tunas. Let's work together. So the Pacific Islands Fisheries Group, that's my partner is Clay Tam, and our fishermen partners said, let's see what we can do. And you can see Ryan Koga, there's Clay Tam, and Makayama, there's Principal down there. We basically said we want to keep it local. Jan back there helped us build some of the equipment too with these guys. Local know-how. Figure out how you all want to tag. What's the best way to do it here? And I want to show you a quick clip. This is Kevin De Silva, who's been one of our amazing taggers. And this is a really beautiful ahi being released with a satellite tag that Kevin and his crew of one, released. And that fish is, you'll see the data that we got. So that's going on right here. And we're very proud of that work. This shows a 53-day track of an ahi that was released off the west side of Kauai, over off Kekaha, and what it did over the June, July, August period that the tag stayed on the fish. And you can see that it ran down past the Big Island, turned around, swam up past Kauai, and was circling back when the tag came off. And for this fish, or these fishes, we also have, this is the first time you're seeing the temperature and depth data, but the color indicates the temperature, and the data indicates the depth that fish was traveling through. I'm sorry that you can't read the axis, but you can see that that's a July record. This was 2014, and notice that ahi spent time in both the warm surface water and the cold water. It spent most of its time above 300 feet, but some of these fish go deeper than, let's see, 1,200, 3,000 feet on occasion. Ahi, we don't know why they make deep dives, but they do it and they come back, whether they're being chased by a false killer whale or a pilot whale, we just don't know, or a shark, but we're starting to understand or confirm what fishermen know about the habits of ahi with this kind of information and from the satellite tags. And this is just a taste of our findings. We're just getting underway. We've had some hardware problems with the tags, but these are tracks of fish. I'm sorry I can't run, it's a web-based data system, but what you're looking at are just the beginning and the end points of ahi, all released by Kevin and his crew this summer. And the lines indicate both the Northwest Hawaiian Islands monument area, and over on the eastern side, that indicates the Eastern Pacific Management Area for IATCC. Our main Hawaiian Islands fish weren't known to travel to the east into the other management area. And these are just tracks of less than 60 days. So imagine what we're going to learn from full year tracks of ahi and big eye and marlins when we can get this work done here with our fishermen partners. And for that, we need our $4,000 tags to work properly. We've had a little less success lately because when manufacturers change their hardware, sometimes it doesn't work. And unfortunately, the tags, ahi, are tough characters, and the tags are breaking a little early after 2 months. They say they're going to fix it, and we're going to have year tracks someday. So I know Sarah mentioned we had a fisherman citizen science tagging of shibis, or small tunas. We started that in the Atlantic with the bluefin, and we hope it will continue here. John, one of our Kona captains, and many others, basically releasing shibi that you don't want to keep or harvest or share with the tag. And some of the tags we released off Kona were caught within 2 weeks, re-released. So it shows you local residency patterns, inter-island travel. So you can learn a lot of stuff with just a simple little $2 spaghetti tag. But our fishermen partners are saying, hey, let's update those even to be like a smarter cheap tag. Maybe your like a RFID, like your iPhone, can be used to scan the tag. That's what we're working on in Kona with our fishermen partners there. So I hope I don't have to answer this question, why fishermen research partners. I hope you get it, that fishermen bring these questions to the scientists. We form long-term, in the Atlantic bluefin, 25-year relationships. That's what we all want to do here for the main Hawaiian Islands. If the federal scientists don't have the funding or the time or the ability to do the work as we did in the Atlantic, we can do it together here as the Atlantic fishermen did. And on the right you see some MIT students and their professors that came to Kona with us and fished for the last 2 years trying to develop new tag technologies for Hawaii. We call it the high tag for Hawaii. And these are just one types of the tags that we're hoping to see developed And you already saw, if you catch one of these guys, please call us. Okay, so this is not too risque, but I know Sarah and the Alliance for Science. We're not always popular when the science we come up with together contradicts people's understanding of the population or contradicts an advocacy message that the data doesn't support. And on the left is Captain Linda Greenlaw. She was in The Perfect Storm. I don't know, she was one of the women captains. And she's a spokesperson for fisheries science and fisheries. She's a writer. She's a very smart woman. And she just harvested that swordfish. On the right is Lizzie Jagger, who's Mick Jagger's daughter. And she's claiming that we should not eat tunas, and that's supposed to be an endangered bluefin. And she also didn't have clothes on. But my point is that we need the best possible science and honest advocates to understand the state of the oceans and sustainable fisheries. And so pay attention, be careful who you're hearing from as far as your source, and be informed if you're a fisherman and a member of the community. It's really important, and against all this, the funding for all of this work, as you all know, has crashed to the bottom at the worst time. But I think the kids in the audience here are going to have the most exciting future as far as ocean science. So my takeaways, our takeaways on behalf of PIFG, our fishermen partners, please go to websites. This is PIFG's website, our website fishtoday.org. Taggit is there too. We publish Lovaya magazine, which is out there. It's about the culture of fishing in the Hawaiian Islands and has a lot of science. So if you need that, I'm happy to give you a card later. And if you like bluefin tuna or want to know more about our stuff, tunalab.org is our bluefin website, and you go to the Facebook page. There's a lot of cool stuff there. And let me finish. Now, watch this. It goes fast. This is the joy of people that come up and go out on a fishing boat just to see the tuna, right? It really is true. I'm sorry for all you local guys that haven't had the chance yet, but pay attention. Let's see if I can get it to run. Oh, no, go back. Get this to run. Oh. Run. If I can pop that.
Look at that little oil.
Watch the bait. Oh.
If I could get another 4 feet out there. It's a big bamboo pole. Try that one again.
Watch it.
Yeah. Come on, baby, you want a shower?
Right, and again, my thanks to all our fishermen tagging partners on Kauai and Kona. Special thanks for the guys that got this going with the fishermen, Mark Oyama, Kendall Long, Don Kobayashi, Noah and Jen here, and Carolyn that encouraged me, and Garden Isle Environment and Economic Development is supporting us as well as far as reaching out as a nonprofit. And I'll end there. Thank you for your attention.
Well, I don't know about you guys, but I'm sure want to go eat some tuna. That was so great, though. I mean, who knew that there was Navy-developed robots from tuna and all about their spawning and everything. It's just awesome. It just shows how one topic that you might eat poke a lot, but how often do we think about the tuna behind it? And you hear stuff, as you say, you might hear stuff on the radio or see in the news, but when you can hear from a scientist
Or a fisherman. Talk to a fisherman.
Who's doing it every day, it's just awesome. So I can't thank you enough, Molly, for helping us out with this, and what a great way to kick off our series, and I just can't wait to have more to come. And yeah, if any of you have any ideas of other topics you'd like to hear about or things you'd like to contribute, let us know. We will. I think I can't wait for the next one, but I just think it was great.
Well, thank you. And I wanted to say, if anybody has any questions, feel free to come on over. Don't be shy. And particularly any students, to anybody, but thanks again, really appreciate it. Sorry, question?
I'm oblivious as to how it's regulated, tuna fisheries locally. Maybe you could.
Sure, and by the way, if you have to leave, don't hesitate. Just don't want to keep anybody, but I'm happy to answer a question. Our Hawaiian fisheries the tunas are managed under the Federal System National Marine Fisheries Service. And the stock assessments are conducted by NOAA, by scientists in Honolulu, and then their results are peer-reviewed by what is called the Science and Statistics Committee of WestPAC, which is the Western Pacific Fisheries Management Council. So the Fisheries Management Council looks at our stakeholders that include fishermen, dealers, and advocates, and some scientists. And so there's the stock assessments done by the feds, NOAA, the WestPAC Council, that is the stakeholder group, and then the Science Advisory is the Science and Statistics Committee. And for example, I was on that committee for 14 years. So it's a system, and then the quotas are set by NOAA, by National Marine Fisheries Service. And just so you all know, both yellowfin and big-eye are judged to be sustainably fished and not overfished, and the population's healthy in this part of the Pacific. So they're all, at least for now, particularly as far as the management measures are in good shape. However, there are quotas, and there are times when the quotas are caught early, and in the case of Shyla knows, if our local quotas are caught, and that sometimes means if they go over what they call the total catch around Christmas for big eye, the big eye quota has been caught, and that's it, shut down, then what happens to the holiday market? So the quotas are certainly in place. Does that answer your question?
Yeah.
Okay.
So I mean, that looked like a really great fish that guy threw back into the ocean. These guys are just volunteering to stay out longer and catch more fish, tag them and toss them.
Yeah. Well, in the case of Atlantic bluefin, there's no way we could have paid any of those fishermen for the value of that. Let's face it. I mean, it goes from $3 at what they call ex-vessel at the dock, as low as $2, but $3, sometimes $12 a pound. It's a 500-pound fish, as high as rarely $24. So we can't pay for that, and we didn't have money to charter. So what happens is they have a daily bag limit in bluefin. Bluefin is incredibly tightly controlled. Each fish is like a deer, has a tag, and so the reason we got our work done is because the fishermen said, we'll keep fishing for this work. And so they caught their bag limit and went in the hold carefully, and then the rest of the day was spent tagging, both from purse seiner, harpoon, and rod and reel. Here, like you said, the ahi that are beautiful, we never want a fisherman to give up his or her catch. So we had the funding at the time to basically reimburse the fisherman for that fish that's released. And in some cases, that particular fisherman released fish gratis. So Kevin tagged and released some fish. He said, I'm going to do this. And that's kind of the spirit of what we're working with. It's incredible, and that's called giving back.
On an international basis, are any other countries doing this kind of research, and is there collaboration, like the Japanese or?
Oh yeah, yeah. I mean, we work with scientists around the world. We work with the Basques, Japanese. They participate in the Atlantic bluefin big time. We communicate. We're personal friends. The answer is yes. And even for our striped marlin work, Taiwan, actually American Samoa, we work in CNMI too. So we're spanning not just the main Hawaiian Islands, and in the Atlantic it's absolutely international. We have collaborators in France, Spain, Israel, Norway, and probably somewhere else, Italy. We have to, because we don't have much funding, so we have to share the work. Yeah. Question?
Hi, thanks for a great presentation. Could you speak a little bit about ICAT and its relationship to the Fisheries Management Council and the data that you're collecting?
That's a really good question. ICAT is different than, say, the Pacific. in that ICAT in the U.S. doesn't have an external peer review. And so each country has its own national science group, and their science is done by each country, and they all come together in Madrid, Spain, and they discuss the science, and they do the assessment. What I think the problem for Atlantic bluefin has been from day one is that there have been no external scientists that have the option to basically peer review or participate. We can only go to meetings and offer opinions, but there's no the Atlantic tunas and billfish and sharks are the only group of fish in the U.S. that are outside of the council system. And that was supposedly for political reasons. In 1981, they thought, we've got to keep the Japanese out of the Gulf of Mexico. And if we have a council, or basically there were political reasons why, in the 80s, it was decided to leave Atlantic tunas and billfish and sharks out of the federal council system. And I think that's been the reason why the science has lagged and been wrong for 25 years. And the last years of my bluefin were spent trying to change it to no avail. And so ICAT has been, for many years, you probably know, allowed countries to overfish. They finally got their act together when the U.S. said, we're going to threaten you. We're going to put trade measures in place. And that was, I think it was finally George Bush's last term. And that's when the overfishing in the Med stopped and the illegal fishing was stopped. And also, Gaddafi also was a horrible pirate. And so they were taking out the spawning fish in the Med during the spawning season. So not only do we have an incredible rebuilding very quickly of bluefin, so when they said they're on the brink of extinction, we knew they weren't because they're everywhere in the West. We saw them with our own eyes from airplanes. But the good thing was at the same time, we knew that there was a vast undercounted body of fish, of bluefin, that no one else wanted to talk about except us and fishermen. And then there was finally the teeth were put in the management measures. So that led to a huge success, I think. What is not successful is the science. It's 30 years behind. The real question for the Pacific bluefin is that I think Pacific bluefin are where we were in 1990, and that is there's a lot of assumptions. There was vast overfishing, probably by Japan, which is acknowledged for many years. But I think, like Atlantic bluefin, we don't have a real clue about what's going on in Pacific bluefin because there's not enough science done yet to know what the real nature of the population is. And we hope that with the management measures and finally attention to science, that Pacific bluefin will be brought out of this brink of extinction and catch up with everybody else. But those are my opinions.
Yeah, well, you can't do good management without good science, so they go hand in hand. And also with the highly migratory species, if management's not coordinated globally, then also, then you're going to have an impact on populations.
Yeah, it starts with the science. It really does, and it's not just models. You've got to have it. You've got to know where they spawn. Question?
Has there been any studies on the genetics of populations to show how distinct they are, and also give any size estimates from a genetic basis?
Genetics have been applied for many, many years for Atlantic bluefin, and it's been tough to get if there's substructure to the population. And the problem was that those methods are always assuming that there are only two spawning areas. So that meant that the two baskets were either or. And there were always, the biggest pile of the samples were unresolved. And now what we showed that it could be that most of the fish are spawning not in either of those two places, in the West, that it basically said go back to the lab or go back and figure it out. Southern bluefin tuna in Australia, they're trying to use genomics to say, okay, let's look back and say if the offspring, who are the parents, and can we figure out the absolute population size from knowing how many, who's in your family. And that conceivably will work. But the challenge is that you have to sample everybody, have a huge sample to look for the relatedness. But yes, absolutely. But is there an answer yet in the Atlantic? Not yet, which is really interesting despite all that. But I think there will be sooner or later. Yeah. And we had a student, I missed somebody. Do you have a question?
I was just going to ask about how many do you think, or how many are you folks tagging, and how do you distinguish if it was tagging, you're following another
Yeah. We've tagged probably since '97. We've tagged. I don't know if I'm going to answer the first part of your question right, but we had funding back then, and Senator Inouye, and we had Senator Gregg, and so we had the money to pay for a lot of tags, and that's all gone. But over those years, we put out about 800 tags on bluefin, big eye, sailfish, and on maybe 20 on swordfish. There, and here we have a total so far of 22 over all the years because we have very small funding for the Pacific. But how do we know they were eaten? I'd love to show you. If we had time, but basically, if you remember that depth, and you saw that ahi. Okay, so what happens is we get the data back and we see, well, that tag came up to the surface or was down here, and all of a sudden the temperature goes warm and stays constant, and the tag light sensor goes dark. It's in the belly, and sooner or later, the shark or the whale or whatever, they regurgitate, and believe it or not, the tags still work. The antennas still transmit, and what you see is in the record, you see dark and warm, pops up to the surface, and then gets ambient, and we probably have out of the ahi, out of the 22. All but 2 are ahi, 2 big eye. We had 3 known cases of tag predation. So, and in bluefin it's much rarer because only big killer whales will eat only smaller. But yeah, it's rare in bluefin, but we're definitely seeing predation in yellowfin and striped marlin, but particularly yellowfin, more than we ever imagined. It's like, whoa, what's going on? Where are all these tags going? Those suckers are out there getting eaten. Sad to say. Yeah.
I guess we're not the only ones that like sashimi.
No.
What about the La Nina and El Nino currents? Have you seen any patterns as far as your tagging and?
We can't answer that yet because too few tags. I think fishermen know when patterns shift, and big eye. We think something happened with big eye, but we didn't have enough. We didn't have tags on. But certainly there was change in distribution last year and the year before. Productivity went way up. Big eye longliners were catching them in different places. So you're absolutely right. All those systems and all the ocean currents absolutely affect tunas. And in the Atlantic, we've done quite a bit of work on that. But as far as Hawaii, we're just getting off the ground here. That's the biggest frustration. We're starting in 2018. In the Atlantic, we started in 1997, and now there's no funding. So if technology has to get better and smaller, the tags have to get cheaper, they have to be better. If we get some wonderful philanthropists that say, I'll invest in the next generation of sensors, we have ideas for a spawning tag to identify that. I think it's all doable right now. It's just a question of, well, how do we all pay for the new ocean science without the federal money? And we have to, and smart people will figure it out. Well, thanks, everybody.